dear friend in Study Buddy channel. Myself Professor K.S. Banker, Assistant Professor, Government Engineering College, Modasa. Today we'll discuss about this operation research subject, and in this subject we'll discuss about this PERT problem. So before start the PERT problem, just I will take this overview what we had discussed in the previous lectures. We had discussed about this 3 time of PERT. In the CPM, only single time has been given, but in PERT there are 3 time: optimistic time TO, most likely time TM, and pessimistic time TP. And we required the find out the expected durations. We required to calculate the expected duration from these 3 time. So this is the formula from which we will calculate the expected duration, that is TE is equal to optimistic time plus 4 times most likely time plus pessimistic time divided by 6, and this is the formula of variance: pessimistic time minus optimistic time divided by 6 whole square. Now the first PERT example, problem number 2. A small project is composed of following activities whose time estimates are listed below, and this example was asked in GTU November 2019 examination. So here activities are given and time are also given. I have just taken this activity for simplicity to understand this problem, but in example this time these activity are not given. I have taken for just your understanding. Okay, so in example only this activity, in example only this activity and these 3 time are given. Now you have to find out this. First, draw the project network, then find the expected durations, that is TE, expected durations, and the variance of each activity. Then calculate the early and late occurrence of each event. Here the early and late occurrence means what? Early means earliest start time, and late means latest finish time of each event. Okay, so we have to find out EST and LFT for each event. Okay, so up to here in GTU example this data have been given, but I have also taken one more option for you, that you have to find out what is the probability of completing the project on or before 14 week. So in addition of these 3, you have to calculate the 4th one also. So let's begin. So first we have to draw the network diagram. So for the activity number 1 to 2, so this is event 1 and 2. So this is first activity 1 to 2, then 1 to 3, activity number 1 to 3, then activity number 1 to 4. So this is 1 and this is 4. So this is 1 to 4. Then activity 2 to 5. So this is 2 to 5. So from here 2 to 5. Then 3 to 5. This is 3 to 5. So here activity 3 and this is 5. Then 4 to 6. So this is 4 and here this is 4, and here you will take this and you can join. This is 4 to 6. So 4 to 6, and last one is 5 to 6. So you can join just this one, so you will get this 5 to 6. So this is your 5 to 6. So our network diagram is completed, but we cannot write this duration on each activity because we have the 3 value: optimistic time, most likely time and pessimistic time. So among these three values we have to find out the estimated time, and this will become our activity time. So before that we have to find out the estimated time. So, and in the example also, in the second number you have to find out the expected duration and variance of each activity. So you have to find out the expected duration and variance for all these activity. So here equation is given for find out the expected duration. So for activity number 1 to 2, this is 1 to 2, the time is 1, 1 and 7. So here just place the time 1, 1 and 7. This is 1, here 1 and 7. Okay, so we will get the answer, that is 2. And for activity number 1 to 3, you will get the 4 estimated time. For activity number 1 to 4, this is 1 to 4, 2, 2 and 8. So here 2, 2 and 8. So you will get this answer 3. Likewise, you will get this expected time using this equation. For activity number 3 to 5 also you will get this estimated time. For activity number 4 to 6 you will get 5. Activity number 5 to 6 you will get the 7 is your expected time. Okay, so whatever you will get this expected time, write down in summary table. Okay, so this is the expected time what we have calculated from these equations. Now calculate the variance of each of this activity. So for variance, this is our equations, Tp minus To divided by 6 whole square. So for activity number 1 to 2, this is 1 to 2 activity, time is 1, 1 and 7. But we have to use only pessimistic time and optimistic time. So difference between 2. So 7 minus 1 divided by 6 whole square, that is 1. So for activity number 1 to 2, variance is 1. For activity 1 to 3, 1. 1 to 4 also, it is 1. For activity number 2 to 5, this is 2 to 5. Okay, it is 0 because 1 minus 1 0. Then 3 to 5, it is 4. And 4 to 6, it is 1. And for the last activity 5 to 6, Tp minus To divided by 6. So 15 minus 3, 15 minus 3 divided by 6 whole square, that is 4. So just place all these value in your summary table, expected durations and variance. Now you can use this value as a single activity time, as you just taken the activity time in CPM examples. Okay, so now you can use this to find out this earliest start time and latest finish time also. Okay, so I just write down all these expected time. Suppose I have considered this 1 to 2 activity is A. Likewise, so A activity, this is D, B. Okay, so I have just mentioned all these expected time what we had calculated. We have calculated. Now using this expected time, find out the early and late occurrence. So early and late occurrence is earliest start time and latest finish time. So I have just calculated this. So for event number 1 both are equal, for event number 3 both are equal, for event number 5 both are equal, and for event number 6 both are equal. So this will become our critical path also. This is our critical path. So in example there is no mentioned to find out critical path, but I have just taken it for your understanding. Okay, so activity 1 to 3, 3 to 5 and 5 to 6 is your critical path, and the summation of this activity is equal to 17. So 17 is your project completion time. So this is your critical activity 1 to 3, 3 to 5 and 5 to 6. Now I've just highlighted all these critical activity in this summary table. See, this is a critical activity and this is the corresponding mean duration and variance, because this value we can utilize in the calculation of probability. So our next point is to calculate to find out the probability of completing your project on or before 14 week. So for that we will consider this critical activity for the calculation of probability. Now here this is your critical activity and here corresponding mean expected time and corresponding variance, and here the total of mean duration is 17 and total of variance is 9. So variance is what? Variance is sigma square. So for the calculation of probability we require the sigma. So sigma is square root of 9, so that is equal to 3 week. Now here just put all these value in these equations. P x minus mu divided by 6. So x is our probability, that is 14 days. Mu is 17 that we have calculated, and sigma, that is standard deviation, okay, that is 3. So our z value in this case is minus 1.00. So using this value we can find out the probability with help of standard normal distribution table, okay, using this value. Now see, this is the standard normal distribution table, in which this is the, here z value are there, this is the z value here in minus, okay, minus z value, and here in first column see 0.00. so in our case our answer is 1.00. so take 1.0 and another column is 0.00. okay, so consider these two column, first and second column. So find out what is minus, where is minus 1.0. so this is 2.0, 2.87, yes, here 1.0, and the corresponding column 0.00, and the intersecting value of these two is this, okay, 1.00 and 0.00. the corresponding point is your probability, that is 0.15866. okay, so this is your probability value, point this one. So now we have seen how to find out the probability with help of standard normal distribution table. So here intersecting value of 1.0 and 0.00 is our required probability, that is 0.15866. so 0.15866 is equal to 15.86%. so you can write your answer. This value is obtained from standard normal distribution table. Therefore the probability of completing the project on or before 14 week is 0.15866 or 15.87%. so your project, the probability to completing your project on or before 14 week is 15.87% only. Okay, so here I am just end up these lectures. If you have any doubt, then please comment in the comment box of this video. Till then, have a nice day. Thank you very much, all of you.